Good morning. This video is intended to give you feedback on what you have done in scaffold number 2. I hope that you get to learn from the comments that I'll be presenting and from the review of some of the components in carrying out a scientific investigation. So what we're going to do here is I'll be showing to you the components in carrying out the scientific investigation or the scientific method in simple term. And then I'll be showing to you some samples that I've seen from your classmates' work. Now, we had work on this learning targets for our scaffolds. So where are we now in our scaffolds? I can identify steps in carrying out an investigation. I can engage argument from evidence. I can create valid conclusion. I can obtain, evaluate, and communicate information. I can investigate scientific inquiry involving chemical reactions. Now, on these learning targets, where are we? Which part? I believe that we're able to carry a portion of them, but there is no in-depth treatment yet. Okay? So, if ever you get to submit scaffold number 3, we will go back again for this part or for these learning targets and try to check what we had achieved. Now, to start with, to address learning target number 1, okay, I can identify steps in carrying out an investigation. And of course, the other components are subsumed in this area as well as you prepare for the scientific investigation. You've been practicing scientific method in the lab when you are asked to perform an experiment. So how does it differ in what you're doing right now or for your scaffold number 3? It is you, or for scaffold number 2, scaffold number 3, number 2, number 3, and for the PC. It is you, okay, who is designing the scientific investigation. This is not new to you since you've been doing this through your science investigatory project. Okay? As seen in the screen, those are the steps of scientific method, and you've learned that it is the process. Scientific method is a process for experimentation that is used to explore observations and answer specific questions. Okay, so just a reminder, not all scientists exactly follow this process. Some areas of science can be easily tested than the others. Okay, or there are probably many versions of this scientific method because there are many scientists. Okay, but even when modified, the goal remains the same: to discover cause and effect relationships by asking questions, carefully gathering and examining evidence, seeing if all available information can be combined in logical answer. Okay, so again, um, even though we show scientific investigation, a scientific method, the series of steps, keep in mind that new information or thinking might cause a scientist or a researcher to back up and repeat steps at any point during the process. Scientific method starts with a question, then don't just limit on that, do background research, and then you construct your hypothesis. You test it with an experiment and you do the procedure. If it is working, no, then you have to troubleshoot. And if it is yes, then you continue, you analyze data and draw conclusions, results align with hypothesis, okay, then you communicate your results. Okay? So if the results align partially, then you have to look into your experimental data and do again. Maybe you can, there's a need for you to reconstruct this, okay? Ask new question, or come up with a specific procedure for your experiment. So the beginning, it's about the problem. We have to start with a good problem. Okay? You need to create a related scientific question. Without a good question, a good problem, your scientific investigation will be much harder, if not impossible. Okay? So, a scientific question usually starts with how, what, when, which, or the way of forming questions. So for a good problem is feasible, original, reproducible, and interesting. Okay, and of course, you want also to be able to build on the experience of others. Then you might look at the sources. Okay, the other sources. Then always remember that the question that you are formulating should contain one factor, shall I say variable, that you can change in the experiment, and at least one factor or one variable that you can measure. That's the component of your question. Now, after which, we formulate the hypothesis, as you have learned that it's an educated guess about how things work, or it is an attempt to answer the question with an explanation that can be tested. A good hypothesis allows you to then make a prediction. Okay? State both your hypothesis and the resulting prediction you will be testing. Example, or checklists. Here is a checklist as your guide, serve as your guide in making a good hypothesis. Is the hypothesis based on information from reference materials about the topic? Can at least one clear prediction be made from the hypothesis? Are predictions resulting from the hypothesis, okay, stated in an experiment? Does the prediction have both an independent variable and a dependent variable? So check your hypothesis when you formulate it. I was able to get this checklist from sciencebuddies.org and I'm sharing it to you. Okay? So from your scaffold number 2, I was able to look at your work and some of the questions that you had in place as well. Okay? One of you had these questions. Which of the 4 liquid antacids will be fastest to neutralize? Which addresses also the claim that I had given to you through the commercial, okay, of the antacid brand. Okay? Next, create another example. Which antacid is most potent and why? So lemon is a natural citric acid. That's a starter. Different brands of solid antacids will react a bit differently than the other. When dissolved in lemon juice, brand A will be most potent of the solid antacid. So maybe what you can do with this hypothesis is to simplify it and check if you have the 2 types of variables. Okay? Revise this a little. Okay? Keep those other stuff already, because this can be, if you are making an introduction, you can place it already, the information there for background purposes. Now, here's another. Which brand of antacid works best in neutralizing acids? Okay, the brand will neutralize the hydrochloric faster than these brands. So you're going to test it. Next, create a testable question again. So here is another scenario that you would like to create, but the only thing that it would have been better if you have addressed the claim of the commercial that I've provided to you, or if you're telling me that you have read about the claims of these two products and you would like to test which is more effective, then this is allowable. Okay, next. Here's another example. Okay, so I hope that you get to see, if ever that I cannot showcase all your work, please try to consider also that um, it might be related to your work and you make some corrections also what went wrong. Now, again, I've mentioned that there should be variables in your hypothesis and in formulating your problem. Again, this is something for you to review. This is just a review. Independent variable is the one that is changed by the scientist. One. Why just one? If you have more than one variable, it will be confusing on your part. Okay, in one question. In one question. I'm referring to one question. Okay, so this will complicate your analysis also. Now, on the independent part, or in the independent variable, so it is the response. That's where you get your response to it. Component of the y-axis, if you will be grafting that, and changes with respect to the implemented treatment. Okay, so for the independent, administered to the experimental group only. Okay, so going back to dependent variables, these are the things that scientists focuses in his observation to see how they respond to the change made by the IV. Okay, by the IV. Now, the number of dependent variable varies in an experiment. Okay, but there can be more than one. There can be more than one. Now here on the screen is about constants. Controlled variables should not be changed among groups. Parameters included depend on the experimental design, or depend on how you work on your experiment. Okay, so those are the things that I hope you get to see also in your work, and try to review your formulation of your the formulation of your hypothesis. The next part are on experiments, materials, equipment, or procedures. I have here some information that will help you also check if you did this correctly in your scaffold number 2. So a good materials list is very specific. Okay, here, you don't just say water, especially if it is really needed. Okay, if you really need the deionized water, so that's it, because it may affect your experiment. So be specific of what you're going to use. Next, what else do you see there? 500 ml. Be specific with your measurement. Tablespoons, teaspoons, cups are not allowed. In science, we highly encourage you to use the volume, to use a specific unit for that. Okay? Because it means it is measured by using the laboratory measuring tools. Then you have their stopwatch with zero point 0.1 accuracy. You try to take a look what you're going to use also. Okay, the tool, the instrument that you're going to use, and be specific of its accuracy. And here, of course, the materials that you need. Be specific. Okay, so take a look at the bad materials list. Now I want you to review what you had in your scaffold number 3 and improve that for your scaffold number 2. In scaffold number 2, improve that for your scaffold number 2. Here are some of the examples that I get to see from your classmates' work. Okay, so that's even more specific, no? Wherein your classmate here placed how many beakers is needed, okay, pH meters, and so on and so forth. Is that clear? So what else after? So there's the materials. You have the amount, okay, with a specific unit, and of course specific uh, concentration there of the solution as discussed. Next, after which you're asked to come up with your experimental procedure. Write the experimental procedure like a step-by-step recipe for your science experiment. Again, the difference with that, when you had performed this in the laboratory, the teacher provided you with the procedure. In your case, you will come up with your own procedure. A good procedure is so detailed and complete that it lets someone else duplicate your experiment exactly. Okay? Repeating a science experiment is an important step to verify your results are consistent and not just by accident. Okay? So, for your experiment, you should plan to repeat it at least 3 times. If you have enough time, the more is better. Okay? So take note. Now let's try to see. I think this is very detailed, and I get to see here that this will be repeated 3 times because there is trial 1, trial 2, and trial 3. Okay? So again, review what you had done in scaffold number 2. And always remember, by the way, to look into your control groups. Experiments also have controlled variables. Okay, so these are quantities that a scientist wants to remain constant. Okay, and he or she must observe them carefully as the independent variables. So that's the control group. Now, you were asked also to come up with your own data table. Before starting your experiment, prepare a data table so you can quickly write down your measurements as you observe them. Okay? Provide captions, and of course, if you're using captions, it must be placed on top of the table, and if you are using graphs or diagrams, should be placed under. Okay, so I hope you get to see what you had done in scaffold number 2. Here are some examples that I would like to share also. So this is the title, okay, and we have trial 1, trial 2, trial 3. So if this is a table, okay, this is correct, and then there it goes. Okay. I have learned. I want also to share to you that scientists, researchers don't just depend on their laptops to have a raw data. They put it in their science journal notebook. So in the future, if you are into research, science research, always have with you your journal notebook that will serve as the diary that gives or provides records where you place your results. Okay? Okay, that is one thing that a researcher should have. Now, for the results and the discussion, please take some time to carefully review all of the data you have collected from your experiment. Try to look at the results of your experiment with a critical eye. Ask yourself these questions according to science bodies. Is it complete, or did you forget something? Do you need to collect more data? Did you make any mistakes? Okay? So, really think about what you have discovered and use your data to help you explain why you think certain things happen. Okay? Next, once the experiment is complete, okay, you collect your measurements and analyze them to see if they support your hypothesis or not. So in conclusion, right? That's for your conclusion. If appropriate, state the relationship between the IV and the DV. Okay? Scientists often find their predictions were not that accurate. The hypothesis was not supported. And in such cases, they will still communicate the results and then go back. They go back and construct a new hypothesis and prediction. Okay? So, answer the question, what else can be done to improve the research? This is to address the recommendation. Okay? Some tips and tricks for you as you prepare for scaffold number 3. Again, form clear, specific, concise hypothesis before analysis. Try to remember that there is no such thing as bad results. Based on your hypothesis, on theory, or in theory, not on a hunch. And always have an end in mind. Okay? So, my dear 10A, when you prepare for your scaffold number 3, kindly go over this video for some of the things that you need to consider to improve your scaffold number 3. Okay? I hope this helps. Bye, and thank you for watching.